Today what we're going to be spending our time in is looking at all the overlapping triangles and seeing how we can prove they are congruent. So we're going to identify them like we just did down here. So down here, the ones actually drawn, I count a total of 8 triangles that I can see in the diagram. Again, that's not including this triangle here, which wasn't drawn, and any other combination of non-collinear points, 3 non-collinear points. So what we're going to do here is identify the different triangles that we see. So how many triangles do you see right here? Just count it out. Anybody?
4, 5.
5 triangles. 5 triangles. Good. We've got this one here. So these are like the angel wings, right? Those ones. Then we've got this one on the top. And then we've got overlapping ones. This one right here. That puppy there. And then lastly, the other one. That's, of course, like that one. So this guy here. Hashtag. That one right there. Okay, so we've got all these triangles, and we have 5 of them. So according to the instructions here, we want to separate and redraw the given triangles. So ABC. So where's ABC? Well, that one is right here. ABC. That's triangle ABC. So let me go ahead and re-sketch triangle ABC right there. And I'm going to separate it from the other one. When I do the separation, I'm still going to use the same letters. I'm not going to change the value. But I do want to make sure that as I draw them, I'm paying attention to what things are congruent and where they go respectively. Okay. So here I've separated them. Now, is there anything that they share? Is there a common side, a common angle, something they share? And the answer is yes. BC is shared by both of them. So when I do the separation, that is if I need to, then clearly I see already the 2 triangles share something. They share a common side. Therefore, by the reflexive property, BC is congruent to itself. So if I wanted to prove these 2 triangles are congruent, here's at least a place to start. I do need other information. I need a pair of angles maybe, or pairs of sides. But right now, minimum amount right there. Now let's look at the next one here for JML. So where's JML? JML is that one. So when I do the sketch, it's going to look something like this. JML. And now NKL is that one there. So something like that. K is here, L is here, and N is here. But what do the 2 share? What do the 2 share here?
Angle L.
Angle L right here. Not simply because there's a letter there. That's the same. But notice here, angle L is this angle right there. And both of them are using that entire thing. As opposed to over here. They both have the letter C in this one, right? This one has the letter C, but it's this acute angle right there. And the blue one has the letter C, but it's an obtuse angle there. So it's true they share the letter, but that doesn't mean they necessarily share that angle. So that's why we have to pay attention. Oh, BC, BC. Okay, they share that side. But over here, they share a pair of angles. Or excuse me, one angle they share. Therefore, those are congruent. All right, so now what we want to do is use these in a proof. Sometimes we're given lots of things. Sometimes we're given just a little bit. But let's see here what we are given. And it's, again, wise for us probably to separate things out in a moment. So let's see what we have and what we know, etc. So I know that triangle ACD, so this entire triangle, is congruent to triangle BDC. So I see the 2 triangles are overlapping, and my job is to try to prove that CE, this one right here, is congruent to ED there. And notice that CE is not part of the blue triangle. And when I say it's not part of it, I'm saying it's not an entire side. It's just a piece of the side. And the same thing, ED is just a piece of the, what looks like the hypotenuse, doesn't have to be, of the red triangle. So it's not like I can say, oh, by CPCTC, because I don't know if those are necessarily congruent yet. So I'm going to have to separate these triangles and see if I can find out some other things about them. All right, so let's see. What do I know? I know triangles are congruent. I know some triangles are congruent, which now gives me 6 things, right? Because of CPCTC, I know 6 things. 3 pairs of angles are congruent. 3 pairs of sides are congruent. Good. Now, what do I need? What do I need? If I consider the bottom triangle, what I need to prove is that this side is congruent to this side. And how can I do that? If I can prove these 2 angles are congruent, then I know that the sides opposite are congruent by the base angles or the isosceles triangle converse. So what's my plan? My plan is to show that I have an isosceles triangle. Well, that's my whole plan. Show that I have an isosceles triangle. But that's actually too much, so let me erase that. What's my big plan? First, I'm going to use CPCTC to show that I have 2 angles that are congruent. And then since I have angles are congruent, I'm going to go to and show that I have an isosceles triangle, or that the sides opposite are congruent. All right, so that's my basic proof. Notice that it's true that all 6 things here are congruent, including these pair of angles are congruent, these pair of angles, and these pair of angles. But there's only one of them that I actually need. I need to know that angle D is congruent to angle C in the split diagram. Over here, it's this angle here and this angle here. So I'm going to use all 3 letters when I make my proof. So I'm going to start off with my given information. So step number 1 is the triangles are congruent. ACD is congruent to triangle BDC, given. Now it's true, I now know 6 things, but I'm only going to focus on one. I'm only going to focus right here and right there. So I'm only going to show that angle BCD on the blue, angle BCD on the blue, is congruent to angle ADC on the red. And why is that true? Because CPCTC, corresponding parts of congruent triangles, are congruent. Now, I can focus simply on the triangle that's on the bottom, this triangle here. So I can focus on that. I have these sides angles congruent. So now by an opposite, the converse of isosceles triangle is, I'm actually done. 3 whole steps in what seems to have been, could have been very confusing. And this would be the isosceles triangle converse. Or the other thing you can say is when 2 angles of a triangle are congruent, then their sides opposite are also congruent.